So in this question we're told that Mary stands on the top of building A and she is 220 meters above the ground. She wants to work out the marked distances y and z in the diagram, the distance from the top of building A to the top of building B, and also the height of the building B. And we're told that these angles are marked in the diagram, and so on and so on. And so basically all the information we need is in the diagram. And we're asked to find out the size of the angle C. So the angle C we can see in here, and we know that buildings tend to be vertical, so we can assume, and we're actually told as well, it's kind of just quite small, that this angle is 90 degrees here, and so this is going to be a case of using SOH-CAH-TOA. And SOH-CAH-TOA is just kind of a made-up word that is a combination of sine being the opposite over the hypotenuse, cos being the adjacent over the hypotenuse, and tan being the opposite over the adjacent. And so all we need to do to find the angle C is first of all set up an equation where we have our two known side lengths. If we look across from C and we find out what side is opposite it, we see that we've got a known length of 220 meters. So this is the same length as the triangle in here, because we can just take that length and bring it inside. And then for our side along the bottom, we've got 154 meters. And the thing to be careful of here is not to use sine, because we actually don't know the value of y yet. And y is the hypotenuse, which is opposite the right angle. And so basically what we need to do is set up an equation in tan, because we've got the opposite, which is across from C, and we've got the adjacent, which is down here beside C, because adjacent is just another word for saying beside. And so we can do that now. So we can say that tan C is going to be the opposite over the adjacent, which, as we've said, is going to be 220 over 154. And so we can just plug that straight in the calculator using our inverse function. So what we can do is say tan inverse 220 over 154 is going to be equal to C, and we plug this in the calculator, we're going to get out a value of 55 degrees. So that is going to be the measure of the angle C in degrees, and that is going to be it for part A. So we just get the value of C, and it is very close to 55. They don't actually say whether to round this off or not, but because it's so close to 55, I'm just going to leave it as 55 degrees. And they keep going on here in part B with a lot of words that really don't say too much new information, but basically what they ask us for here is to use the theorem of Pythagoras to work out the distance marked y, and to use trigonometry to work out the distance marked z, which is the height of the building B. So that's all I pay attention to for part B, is just to basically use Pythagoras and trigonometry to find y and z, and all the information we need is already in our diagram. And we already found C, so we can even put that in if we needed to, but we're just going to see actually what we need to do here. So I'd always start with Pythagoras, because everyone loves Pythagoras and we're very used to using that. And so we can see that y here is going to be our hypotenuse of our triangle, and then our two sides in the triangle are going to be 220 and 154. And so we can set up an equation now where we say that y squared, or the hypotenuse squared, is going to be equal to 154 squared plus 220 squared. And so we can just plug this part, this 154 squared plus 220 squared, into our calculator to find the value of y squared. And so y squared is going to be 72,116, and so to find y we just take the square root of both sides, and we get that y is equal to 268.544, but we need to give this correct to the nearest meter. That's the one part that actually did matter in this wordy kind of mess in part B, but essentially we just need to round this off, so we just need to round it to the nearest meter, and that is going to be 269 meters. So that is going to be our final answer for y. And so now our next goal is going to be to find the value of z. And so if we go back up to our diagram, we're just going to basically figure out what we would need to do this. And so we know actually a good fraction of z already, because we know that the height up until this point, so kind of up until here, so that would be over here on z, that value is going to be 220. So we already know that value up until that point. And so really what we're looking for is just the remaining fraction of z over here. So this kind of basically this side length of the triangle in here, and to find that we're going to have to use trigonometry, as they said. And so what I'm going to do basically is first of all bring our 154 up, because we know that we've got 154 across from the left hand side here all the way over to the right hand side, because this is just a square, and we can see there's 154 here on the bottom, so that's kind of an important thing to spot in order to do this. But once we've done that, it's actually very simple, because we can see that if we call this value we're looking for in here x on our diagram, so I've written that in blue, we've basically got an angle, and we've got the adjacent, or the side beside the angle, and then we've got this x, which is the opposite. And so once again we can use SOH-CAH-TOA, which we used for part A, to find out the value of x, except instead of finding out an angle now, which we did in part A, we're going to be using it to find out the length of a side. And so tan of 20 is going to be the opposite over the adjacent, And so just to reiterate, we know it's tan because we don't actually have the length of the hypotenuse up here, but we do have the length of the opposite side of the angle and then also the adjacent side below it. And so tan 20 is going to be the opposite of the adjacent, which in this case is going to be x over 154. And so if we basically rearrange this now to get x on one side, we can get that by multiplying across by 154, we get that x is equal to 154 tan 20. And so we can plug that straight in the calculator to find the value of x. And what we get is an answer of 56.051, but then rounding that off once again to the nearest meter, which they asked for both of these, we get that x has a length of roughly 56 meters. And so we're almost done here now. So because we're looking for the value of z rather than x, so we found x now, which is, if we look in our diagram, this length up here, and we already have our height of kind of the first good portion of z, which was 220. And so basically to find the full value of z, we can say that z is equal to 220 plus 56, and 56 is our x that we found. And so 220 plus 56 is going to be 276 meters. So that is going to be it for this question.